great minds. How are you doing today? Trust you are doing very good, and I know you are prepared for today's class. Welcome to Basic Science class. Kids, our topic for today is magnets. And some of the subtopics we'll be looking at are 1. What is a magnet? 2. What metal is attracted to magnets? 3. Where is the force of the magnet the strongest? 4. What is a magnetic field? 5. What happens if you bring two magnets together? 6. Uses of a magnet. Have you ever seen a magnet before? Do you know what a magnet is? A magnet is an object that can attract, that is to pull towards itself, or repel, which is to push away objects. That is, a magnet is an object that can either put other objects towards itself, which means to attract, or push other objects away from itself, which is to repel. Now, from this picture, we can see two arrows coming together. That is to attract. And we can see two arrows going in opposite direction. That is to repel. So a magnet can either attract, that means to put towards itself, or repel, that is to push away other objects. Now, these objects that the magnets are attracted to are ions or contains ion. Like these pictures, we can see various examples of objects a magnet can attract to itself. We can see nails, paper clips, we can see coins, and so on. So any object that contains ion can be attracted to a magnet. Magnetic poles. Magnetic poles. Every magnet has two poles. Every magnet has two poles. They are the North Pole and the South Pole. Each of these poles is known as the magnetic poles, or the pole of a magnet. Even if you cut a magnet in halves, each new magnet we have will always have a North Pole and a South Pole. So, the pole of a magnet that points towards the north is known as the North Pole, while the pole of a magnet that points towards the south is called the South Pole. Remember, every magnet has how many poles? 2 poles, and they have the North Pole and the South Pole. So, each of these poles are known as the magnetic poles or the pole of a magnet. Now, even if you cut a magnet in halves and you have new sets of magnets, this new set of magnets will always have a North Pole and a South Pole. So no matter how many times you cut a magnet, you will always have a North Pole and a South Pole. Now, the force, which is the push or the pull of a magnet, is strongest at its poles. That means the two ends. You can see these two ends, that's the North Pole and the South Pole. So the force, which is the push or the pull of a magnet, is always strongest at its poles. So next time someone asks you, where is the force of the magnet the strongest? What will you tell the person? At its poles. Magnetic field. Can you see the space indicated with lines around these two magnets? Can you see it? It is known as the magnetic field. We cannot see it with our naked eyes, but we can feel it. So what is this magnetic field? What is this space surrounding the magnet? What is it? A magnetic field is the space where the force of the magnet can be felt. Wow! Remember, I told you the force, which is the push or the pull of a magnet, is strongest at its poles. But now, a magnetic field is that space where you can feel the force of a magnet. So even as the force is strongest at its poles, so that space where you can feel the force is known as the magnetic field. The magnetic field surrounds the magnet. What happens if you bring two magnets close together? Have you ever imagined? If you bring two magnets close together, what will happen? When you bring two magnets close to each other, the opposite poles will attract, while the same poles will repel each other. Wow. Remember, I told you every magnet has how many poles? Two poles. What are they? The North Pole and the South Pole. So, as seen in this picture, the north poles of both magnets will repel each other. Remember, to repel means to what? To pull away. So will the south poles of both magnets. Now, you may ask, why are these poles, both the north poles, like the same poles, the north poles and the south poles, why are they repelling each other? Because they are the same poles. Remember, I told you that the same poles will always repel each other, while the opposite poles will always attract each other. That is, the north and the south poles will always pull towards each other, we always push towards each other. And they attract each other because they are what? Unlike poles. You can see it here now. So you can see, unlike poles, we always attract each other, while like poles, we repel each other. Make sure you don't get it confused, okay? Unlike poles, we always attract, while like poles, we always repel. For example, you have magnet A and magnet B. They are two different poles, right? A and B, are they the same? No, they are different. So those two different, A and B, will always do what? Attract each other. You can see in this diagram, there's a blue magnet and there's a red side. So the blue and the red side, they are different. So they will always come together because unlike poles attract. Now you can see same poles, like you have an A magnet and another A magnet. They will always repel. You can see that the blue end of a magnet and the blue end of another magnet will always cause a separation, that is a repelling force. So I believe you know the reason. Now we would be watching a video that further explains this.
Our friendly bar magnet, Barry, has two poles. He has a north pole and a south pole. He knows he can attract objects made of iron. But now he wonders if he can attract his fellow magnets. Why don't we join him as he seeks answers to his question? While Barry was walking, he saw another bar magnet on the way. He was excited to see if the bar magnet was attracted to him. As he got nearer and nearer, the bar magnet slowly got nearer to him as well, until the bar magnet's south pole was attracted to Barry's north pole. Barry was happy. Not only are magnetic objects attracted to him, his fellow magnets are too. He kept walking. He saw a cylindrical magnet. But this time, as Barry got nearer, the cylindrical magnet moved away from him. He kept getting nearer, and the magnet moved away. Why is the bar magnet attracted to Barry? Why isn't the cylindrical magnet attracted to him? When Barry's north pole came near the bar magnet's south pole, the magnets were attracted to each other. But when Barry's north pole got close to the north pole of the cylindrical magnet, they repelled each other. For magnets, when two unlike poles, the north pole and the south, come together, they attract. On the other hand, when two like poles, the north pole and the north pole, or the south pole and the south pole come together, they repel. So what should Barry do to attract the cylindrical magnet? He should move to the other end of the cylindrical magnet. Gotcha! Now Barry knows how to attract other magnets.
Welcome back. I know you have a better understanding of what happens when two magnets of opposite poles or same poles are brought together. Now we'll be looking at the uses of a magnet. Do you know that magnets are used by businesses and in our homes here every day? Yes, it is. So some of the uses of a magnet are: 1. Magnets are part of telephones, computers, and even speakers. Number 2, can operators use magnets to hold the can in place? Number 3, refrigerator doors use magnets to keep them closed. Number 4, magnets are used to make doorbells ring and to turn machines such as washers off. And number 5, large and powerful magnets are used in the junkyards to lift heavy objects. Example is the crane. Thank you for watching. I believe you have learned something new. Don't forget to do your assignment. Bye.